Hi, I'm Mithilesh. Today we're going to look up quadratic equations, complete square method, and nature of roots of quadratic equation. General form of a quadratic equation. General form of a quadratic equation is ax squared plus bx plus c is equal to 0 and a not equal to 0. A, B, C belongs to real numbers. Therefore, any polynomial of degree 2 is called a quadratic equation. Hence, this becomes the condition for a polynomial to become a quadratic equation. Degree being 2 and a not equal to 0 are the respective conditions here, 1 and 2. Let's see it with an example here. X minus 3 into 2x plus 1 is equal to x into x plus 5. On the evaluation of both the sides, we get 2x squared plus x minus 6x minus 3 is equal to x squared plus 5x. On solving this, we get 2x squared minus 5x minus 3 is equal to x squared plus 5x. Bringing x squared to the other side, I am left with x squared. 5x adds to the minus 5x here and it becomes minus 10x minus 3 is equal to 0. So this is a second degree polynomial equation of the form ax squared plus bx plus c. A being 1, b being minus 10 and c being a minus 3. So my a is not equal to 0 and my highest degree of the polynomial equation is 2. Hence it is a second degree polynomial equation. Both my conditions satisfy here and hence this is a quadratic equation. We could solve a quadratic equation with the help of factorization method as we have discussed earlier. Let's see it with an example once again. My quadratic equation here is 2x squared minus 5x plus 3. My product here is a 6 and I have to take such divisors or multipliers whose sum or subtraction yields me a minus 5. 6 multiples may be 2, 3 or 3 into 2 and so on. So it would become a 3 and a 2. Does a plus 3 and a plus 2 satisfy my equation? No, it doesn't because it gives me a plus 5. A minus 3 and minus 2 would be perfect. So, expanding my equation into 2x squared minus 3x minus 2x plus 3 is equal to 0. Taking x common from here, I get a 2x minus 3. Taking a minus 1 common from here, I am left with 2x minus 3. Taking 2x minus 3 common from here, I am left with x minus 1 equals to 0. Hence, the solution to my equation is 3 by 2, 1. I have already laid emphasis on theoretical way of approaching problems. So, I would like to discuss one problem of such sort so that you have an idea about them. The product of Sunita's age 2 years ago and her age 4 years from now is one more than twice her present age. What is a present age is the question. How do I proceed with such a type of problem? The main point where this problem is revolving around is Sunita's age. So let present age of Sunita be x. This is my basic assumption. Such an assumption would be perfect and the question it will help you solve out. So Sunita's age 2 years ago will be x minus 2. Why are we finding this? Because in the question it says so. After that, Sunita's age after 4 years from now would become x plus 4. It is very simple. If you are at the age of 5 right now, after 5 years, if I ask you what will be your age, you would simply say 10. That is how this goes on. Let's continue. This question is saying that after 4 years, the product of Sunita's age 2 years ago and 4 years from now, that is x minus 2 into x plus 2, is a product between them, is equal to 1 more than twice her present age. Twice her present age would become 2x and 1 more than that becomes 2x plus 1. So, according to my equation or the question problem statement, my equation would be framed as x minus 2 into x plus 4 is equal to 2x plus 1. You solve this, you get your answer. Complete square method. This is another way to obtain the roots of the equation. Let's check it out with an example. What actually complete square means? Complete square means a plus b whole square. I hope all of you remember this expansion. You just need not do anything, just convert these quadratic equations to such a form. Expansion of a plus b whole square, a squared plus b squared plus 2ab. You need to convert the quadratic equations into this form. 4x squared will be my a square, so my a would become 2x whole square plus I want my 3x in terms of 2ab, so I write my 2 as it is, a 2x. Decide now what will be your b. I need to eliminate this 2 into 2, 4, so I write a 3 by 4. Is it not simple? So I need to have this b square also, so I add a 9 by 16 and a subtract 9 by 16 and remains is plus 5. Sorry, I need to adjust here. Now my a square plus b square plus 2ab will turn into a plus b whole square. So a little bit of rearranging here will be leading to 2x plus 3 by 4 whole square plus 5 minus 9 by 16. This is what I mean by complete square method equal to 0. I just need to evaluate this term, put on a root over this term, cancel the square on both sides and then evaluate for my x. This is as simple as that. Not only does this help in my solution, but also it helps in determining the nature of roots. If b square minus 4ac greater than 0, then it has real roots, and if it is less than 0, it has non-real roots. Wondering what is b, a and c? It is obtained from the general form of equation ax square plus bx plus c. Always take care of the signs for a, b and c. It is very important. Hence the roots of the quadratic equation become minus b plus root d by 2a and minus b minus root d whole by 2a, where d is equal to b square minus 4ac. This formula is known as the quadratic formula. We can also determine the nature of the roots based on the value of d. Therefore, if d greater than 0, then two distinct real roots are possible. If d equals to 0, two equal real roots are possible, and if d less than 0, then no real roots exist. Why don't real roots exist when d is less than 0? Because they lead to complex formation. Hope you've understood. Thank you.